G'day and welcome to the second video on locus of points. Previous video we looked at locus of a points that actually make the shape of a circle. This time we're going to find like a different shape and we'll see what happens. Okay, so what we need to do is we need to find the series of points that are equidistant or equal distance from these two particular points here. So again, let me just draw what's going on here. You've got the point 1, 1, which is there, and you've got the point 3, where did it go? 1, 1, and 3, 5, which is somewhere there. And what we need to do is we need to find the series of points that are equal distance from this point to this point. The easiest one to think about is probably this one in the middle, just here. Oh, this is not working for me all that well. Keeps disappearing. No good. What is going on? There we go. That's a very rough point. So I guess this point here is equal distance from there to there. But if we started to play around with this a little bit, we could actually find a point over here that is actually equal distance from there to there too. And a point over there which is equal distance, and a point over there, and a point over there, and a point over there. And what we're going to end up finding is that there's actually a straight line, and all of these points here are actually going to be an equal distance from these two particular points there. And that's actually what I want to find. I want to find this relationship here. Previously it was a circle. In this case it's going to be a straight line. Okay, so again I'm going to use these particular points. I've got 1 and 1, and I've got 3 and 5, and I'm going to find this generic random point x and y. Okay, and I'm going to use the distant formula again because it's equal distance to I guess prove that that this is a straight line, or show you that it actually works out to be a straight line. So I'm going to get the distance between these 2 points, 1, 1 and xy, and the distance between xy and 3, 5, and make them equal each other. So again, the distance formula is x minus 1 squared plus y minus 1 squared, and I'm going to make that equal to say x minus 3 squared plus y minus 5 squared. And hopefully when I do all the algebra of this, I end up getting a straight line. So let's just do that, square both sides and expand them. I get x squared minus 2x plus 1 plus y squared minus 2y plus 1 equals x squared minus 6x plus 9 and plus y squared minus 10y plus 25. Okay, now I'm going to do some creative cancelling down here. X squared on both sides can eliminate themselves. Y squared on both sides can eliminate themselves. And so now I can just put together everything and hopefully it all works out nicely. So over this side I've got negative 2x minus 2y plus 2. And on this side I've got negative 6x minus 10y plus 34. Now I'm going to rearrange and find the answer, which will be nice, I hope. I'll leave 8y on that side. I'll just add 10y on both sides. On this side I'll get negative 4x, and I'll also get plus 32, and divide everything by 8, and I get negative a half x plus 4. And that relationship there should be the middle, smack bang in the middle of these 2 points, no matter what x value I choose, no matter what y value I choose. Okay, the next thing that I'm asked to do is to show that this is the perpendicular bisector of line segment QR. So this one here is Q, this one here is R, and I'm asked to show that this line here bisects, cuts in half, exactly in half, so those distances are the same, and it's actually perpendicular as well. I already know that it's that's the bisectors, and it cuts it in half because I know that these distances have to be the same. But is it also perpendicular? Well, I guess the easiest way to do this is to find out the gradient of the line QR, and that's just going to be y2 minus y1 over x2 minus x1, which ends up being 4 over 2, which is 2. So the gradient of QR is 2, and the gradient of my line is negative a half And I know that if you've got the negative reciprocal of this gradient here, I'm not explaining this very well, but if the gradient of QR is 2 and the gradient of the other one is -1 on 2, these two are actually perpendicular. So these two lines are in fact perpendicular, and that's what I've been asked to find out. So I hope that has helped, and look for the next videos, which will be on parabolas, locus of a point using parabolas. So thanks very much.